Hello students, myself Er.Faheem. Today we will discuss about class 12th physics chapter 2, that is electrostatic potential and capacitance. This chapter have many topics. Now in this video we will discuss about electrostatic potential and electrostatic potential difference. First we will discuss electric potential difference. What is electric potential difference? Electric potential difference is the amount of work. Which type of work? Let us suppose a charge is here and a test charge is placed at that point. If the charge is moving from point A to point B, point A to point B, there will be a work done because a force is acting, a repulsive force is acting in this direction, because test charge is always positive and this charge is also positive. Positive, there will be a repulsion, means we have to work on charge, test charge, to take it from point A to B. That means we can say that potential difference means potential difference delta V, potential difference is equals to potential at B minus potential at A. That is equals to work done from A to B upon Q naught. If we talk about the definition of electrostatic potential difference is work done in going from point A to point B per unit test charge, or we can say that work done upon Q naught is equals to the potential difference between these 2 points. Now we will discuss electric potential. Electric potential. First point was electric potential difference, and the second point is electric potential. What is electric potential is the same definition, but electric potential V is equals to W from infinite to a particular point, or simply we can say that W upon Q naught. Means electric potential is the work done, amount of work done from infinite to a particular point, per unit test charge. Definition of electric potential difference is amount of work done from point A to B per unit test charge is called electric potential difference, and electric potential is the amount of work done to carry a charge from infinite to a particular point, from infinite to a particular point, let us say it is B, per unit test charge is called electric potential, or we can say that W is equals to Q naught into V. Next point is electric potential due to a point charge. Electric potential due to a point charge. Electric potential due to a point charge. Due to a point charge. Let us suppose this is a charge, Q charge, and we need to calculate electric potential due to this charge at this point. Let us suppose that point is point B, and if we take a unit charge that is coming from infinite to a particular point. The particular point is at a distance of r from a stationary charge, due to which we need to calculate potential difference or potential. Let us suppose the charge is coming from infinite to B, any general point. Let us suppose that point is A. At that point, the distance of the point from the stationary charge, let us suppose this is x. Force will be what? Force will be equals to K. K will be equals to what? K is 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught Q1 and Q2. This charge is Q naught, that means test charge. Q and Q naught upon x square. This is the force. This is the force, electrostatic force in this direction. Okay. We need to calculate work done. What is work done? W is equals to integration of f dot dx from infinite to a particular point, because the test charge is coming from infinite to a particular point, means at a distance r from the stationary charge. From infinite to a point. Integration force is equals to K Q naught upon x square dx into angle between force and displacement, because electrostatic force is in this direction and displacement is in this direction. Both the directions are in opposite direction. That means the angle is cos 180 degree from infinite to r. K, Q and Q naught is constant. It can be taken out. Q and Q naught. Integration of 1 upon x square, it can be written as x to the power minus 2 from infinite to r, and cos 180 is minus 1. We can write minus sign here. That will be equals to minus K Q naught integration of x to x square, x to the power minus 2. X to the power minus 2. Integration of x to the power minus 2 will be minus 2 plus 1 upon minus 2 plus 1 is equals to x to the power minus 1 upon minus 1, or we can write minus 1 upon x. Minus 1 upon x, or simply we can write here integration of x to the power minus 2, that will be equals to minus 1 upon x from infinite to r. Minus sign can be taken out. It will be K Q naught 1 upon x from infinite to r, or we can write K Q naught 1 upon r minus 1 upon infinite. We know that 1 upon infinite is 0. Finally we can write W is equals to K Q naught 1 upon r. Simply W is equals to K times Q naught upon r. This is the work done, but we need to calculate electric potential. We also know that electric potential V is equals to W upon Q naught. Q naught means V will be equals to K. If we divide by Q naught will be cancelled out. K Q upon R. the potential due to a point charge at any point at a distance r, that will be equals to V is equals to K Q upon R. We can also write V is equals to 1 by 4 pi epsilon naught Q upon R. This is the electrostatic potential due to a point charge. Next point is electrostatic potential due to an electric dipole. Means in next topic we will discuss electric potential due to an electric dipole. Electric dipole will have many points, like electric potential may be on the axis, it may be equatorial point, it may be on any general point. First, electric potential due to an electric dipole on the axis. Let us suppose this is minus charge and this is plus charge. This is electric dipole, and we need to calculate electric potential at any point on the axis of the dipole. Let us suppose this is the point P where we need to calculate electric potential due to these two charges. Distance between the two charges, in general we take what? That is 2a, and from midpoint the distance of the point P is, let us suppose, R. Total potential will be at point P. Total potential at point P will be equals to potential due to positive charge plus potential due to negative charge. Potential is an scalar quantity. V due to positive charge means distance between this positive charge and this point P. This distance is R and this is A. That means the distance will be R minus A. Means K means 1 by 4 pi epsilon naught Q plus Q upon R minus A plus K times minus Q due to this charge at that point A plus R. We can write K and Q common, 1 upon R minus A minus 1 upon R plus A. Simply we can write R minus A, R plus A, R minus A into R plus A. That will be R square minus A square. And upside R plus A minus R plus A. R cancel out, plus A, 2A means K Q 2A upon R square minus A square. Q into 2A will be what? Q into 2A. We know that Q into 2A is equals to P, that is electric dipole moment. Or we can say that electric potential at point P is equals to K P, Q into 2A equals to P R square minus A square. This is the formula of electric potential due to an electric dipole on the axis of the dipole. If R is very greater than A, that means A is 0 or A square. A square is approximately equals to 0. That means V, potential at point P, is equals to K times P upon R square. Or we can write P is equals to 1 upon 4 pi epsilon naught, 1 by 4 pi epsilon naught P upon R square, means potential is inversely proportional to the square of the distance. But due to a point charge, potential is 1 upon 4 pi epsilon naught Q upon R. Due to a point charge, potential is inversely proportional to R, and due to an electric dipole, potential is inversely proportional to the square of the distance. These 2 points you must keep in mind. Okay. Next, we will discuss about the unit of electric potential. What is unit of electric potential? Potential is W upon Q, means unit of potential will be what? W means work, joule per coulomb, or simply we can write volt, means unit of potential is joule per coulomb, or we can say it volt, or simply voltage. Let us move to the next point, that is electric potential due to an electric dipole on the equatorial point. Equatorial point, we need to calculate electric potential on the equatorial point. On the equatorial point. Equatorial point. What will be the electric potential? Let us suppose this is minus Q, this is plus Q, and equatorial point is, you may take here, equatorial point is this point. That means potential due to this point, potential due to this point by the negative charge and by the positive charge, because electrostatic potential is a scalar quantity. That means we need to sum up with an algebraic summation, means potential at point P will be equals to potential due to positive charge plus potential due to negative charge. Let us suppose this distance is R, and this distance is 2a, means this distance is A and this is R, and the hypotenuse will be equals to under root A square plus R square. Potential due to a point charge K Q plus Q, due to plus Q, upon distance between the point and the charge, that is A square plus R square, plus K due to negative charge K minus Q upon distance is same, that is A square plus R square. If you see it, these two magnitudes are same but in opposite direction, only there is a change in the sign. There is positive and there is negative. That means if we add these two quantities, the sum will be equals to 0. That means potential at point P is equals to 0, or we can say electric potential due to an electric dipole on the equatorial point will be equals to 0. Always it may be any point. Okay, next point, electric potential due to an electric dipole on any point. It means we need to calculate potential due to an electric dipole in a general point on any point. It may be on the axis, it may be on the equatorial point, it may not be on the axis and may not be on the equatorial point, means any general point. Okay. On any point. First, see, this is electric dipole, this is negative charge, and this is positive charge, and you may take any general point, P point here. This distance is, let us suppose R2, and this distance is, let us suppose, R1, and from middle point this is R. If you take an arc equal distance, this distance equal distance, this is perpendicular, this distance, this is R2, that means this is R2 and this is R1, that means this distance will be equals to R1 minus R2. This distance from this point to this point is R1 minus R2, and this distance is 2a. This point is a general point on any plane. We need to calculate potential at that point. That means potential at point P is equals to potential due to positive charge plus due to negative charge. Potential due to positive charge plus potential due to negative charge. That will be equals to what? K by the positive charge, Q upon R2 plus Q minus Q upon R1. You can take K and Q common. This will be 1 by R2 minus 1 by R1. This minus is here. You can write K Q R1 R2 R1 minus R2. If this is theta and if R is very greater than A, means this is very large as compared to this length, that means this theta is approximately equals to this angle, means this is also theta, approximately equals to theta. If this is 2a, this will be that distance a along the theta, it will be 2a cos theta, and this will be 2a sin theta, means R1 minus R2, and this length is equals to 2a cos theta. We can write in place of R1 minus R2 as 2a cos theta, means R1 minus R2 is cos 2 theta. Potential at point P is equals to K Q R1 minus R2 is 2a cos theta upon R1 and R2. If this is very small, that means R1 and R2 multiplication of R1 and R2 is approximately equals to R into R, means R square. That is R square. You can write Q into 2a, that is also electric dipole moment, K P cos theta upon R square, means Vp, means net electric potential at point P is equals to K P cos theta upon R square. There will be special cases. Let us suppose first special case is what if theta is equals to 0 degree or 180 degree, means this point is here, means 0 degree, theta is 0 degree, or here maybe it may be if this is that point, that will be similar to the derivation, that means 0 degree, means if cos theta is 0, that is cos 0 is 1, that will be equals to potential at point P will be equals to K P upon R square, K P upon R square. This will be positive. If we take 180, that means this point is here, means at here maybe, and for 0 degree point may be here. If the point is here, means cos 0, the potential is positive, but if this point is here toward the negative charge, that means cos 180 is minus 1, that means Kp minus 1 upon R square, means minus Kp upon R square. First time it will be plus and second time it will be minus. If P is toward the positive charge, this is positive, and if the point is toward the negative charge, this is negative, because the potential at that point will be more due to negative charge, and at that point potential will be more due to positive charge, that will be positive. Okay. Next point is electric. Next topic is electric potential due to a group of point charges. Electric potential due to a group of charges, means if there are more than 2 charges, what will be the potential at a point due to these individual charges? Simple, very simple. This is like algebraic summation. Too many charges there. If potential at any point due to many charges, Q1 upon R1 plus Q2 upon R2 plus Q3 upon R3 plus Qn upon Rn. This is the algebraic summation, because the potential is a scalar quantity. Means we can take K common, Q1 upon R1 plus Q2 upon R2 plus Q3 upon R3 plus plus Qn upon Rn. Electric potential due to a system of charges. And last point is electric potential due to a uniformly charged spherical shell. Uniformly charged spherical shell. Uniformly charged spherical shell. Potential, first point, if the point is outside the sphere, the point is outside the sphere, if we need to calculate potential at outside point, P point, that means this spherical shell, it may be positive or negative, due to, if this is positive, potential at point P due to this sphere will be equals to V is equals to 1 upon 4 pi epsilon naught, 4 pi epsilon naught if the distance is r, q upon r, like point charges. Means if the point is outside, the spherical shell will be considered as a point charge. If the point is on the surface of the spherical shell, on the surface, V is equals to 1 upon 4 pi epsilon naught q upon capital R if the radius of the spherical shell is capital R. If the point is inside, we know that electric field inside a conductor spherical shell is 0. Electric field is 0, that means potential will be constant. Potential will be constant, that is equals to 1 upon 4 pi epsilon naught q upon r. Why potential is constant? We will discuss in the next topic. Means topic 2. The potential inside is 1 by 4 pi epsilon naught q upon r square. If we draw a graph, this is the distance r. Potential V, potential is constant at 0, at any point on the surface. Potential is constant up to the periphery of the spherical shell, and then after potential will decrease, means potential is inversely proportional to the distance, means potential will decrease like that. V is inversely proportional to R, and V here, V potential is equals to 1 upon 4 pi epsilon naught q upon R, means constant. I hope you understood all these topics. Next topic we will discuss about other topic. Thank you.